Good afternoon. My name is Dale Hartley and I am Business Development Director for Syrinix Ltd. And I'm delighted to have the opportunity to introduce the company and more specifically the TransientMinder solution. Incidentally, I believe that TrunkMinder was also introduced at the first tag group event to take place in Australia just a couple of years ago. At Syrinix, we're involved in automated pipeline monitoring, more specifically with respect to monitoring of early stage leaks, pressure transient activity and location of pipe bursts, with the overall aim of providing water utilities with the tools and information to better understand and manage their assets and ultimately prolong the life of their pipe network. Syrinix was born out of university research originally funded for and by Thames Water. This was specifically with the aim of delivering a solution for finding small, early-stage leaks in critical large-diameter pipelines. TrunkMinder was the resulting solution delivered by Syrinix and is now widely used across Thames Water and elsewhere. More recently, a commercial business was wrapped around the strong R&D facility, and although R&D remains at the core of Syrinix, headed up by Dr. Paul Limford as our CTO, seen here on the left, we are now pushing out internationally with a broader range of solutions, one of which is TransientMinder that I'd like to present today. These are some of our more recent clients, almost all of which are now using TransientMinder to assist with their assessment and network calming programs. You will see listed here Pure Technologies, who many of you will know from their SmartBall and Sahara systems. Pure are implementing the Syrinix TransientMinder solution as part of their work in the state of Washington in the USA. So tackling pressure transients. Through the course of research and working with water utilities, it became apparent that harmful pressure transients is an area causing specific problems, but an area that is not yet properly understood. In introducing the TransientMinder, I'll run through the key factors, including defining a pressure transient, causes and detection, practical implementation, and event source identification. If we look at this table, in very brief summary, whilst short events with a low amplitude and long events with a high amplitude are likely to fall under the category of normal pressure fluctuation, a pressure transient would be an event with a very short duration but a very high amplitude. These events are not only harmful, with recent utility research suggesting that they frequently cause bursts in as much as 60% of cases, but they are notoriously difficult to identify. And even where the pressure event is captured, it often remains difficult to identify the source and the cause. So what causes pressure transients? Well, it's certainly not an exhaustive list, and we are familiar with many of those listed here. These include everyday utility activities such as simply opening and closing of valves. How many times have you been on site, closing a valve to isolate a leak, only to have that very valve closure result in another 2 bursts? Hydrant flushing and high demand client usage are also everyday utility activities that can and do cause harmful pressure transients. The maximum theoretical pressure wave velocity in water is 1,483 meters per second, though in reality, based on practical site observations, velocities are generally lower, such as those indicated in this table. When considering pressure wave velocities, we have 2 choices. We can use a velocity based on empirical estimation, or we can calculate velocity using out-of-bracket events. Obviously, the more accurate the velocity, the greater the reliability and accuracy of the positioning of the transient source. But even with an acceptable level of inaccuracy, with TransientMinder we are now able to reasonably indicate the source of the transient, to within plus or minus 80 meters for example, certainly close enough to be able to help identify the source and therefore the cause of the pressure transient. So in conclusion, to offer a proper means to tackling and understanding harmful pressure transients, it's understood that the resulting solution obviously needs to detect transient and notify the user accordingly. And then rather than jet washing the user with endless data, only the relevant data containing all the information on the transient should be sent to the client, although all the surrounding data should be captured. And further, the solution should offer an ability to track the transient as it travels through the network and then help the user identify the source. The online cloud-based software platform into which all the data from TransientMinder is sent is named RADAR, an acronym for Real-Time Assessment of Data and Asset Risk. And yes, we did settle on the name and then worked in the appropriate words. This is a screenshot of the software showing the same pressure transient captured by two separate TransientMinder units deployed 3.2 kilometers apart. The pressure scale is on the left vertical axis and the time scale is on the horizontal axis along the bottom. At the point of the first TransientMinder deployment, shown here as a green graph, there is a standard operating pressure of around 7 bar or 100 psi. Then about 3 minutes into the displayed monitoring period, the pressure surges up to around 19 bar, 275 psi, far exceeding the safe pressure rating of the pipeline. Zooming in further to that same graph, with the time axis along the bottom now displayed in single seconds, the maximum amplitude of the pressure transient occurs at a speed of around a 20th of a second. This would obviously not be detected using normal pressure logging intervals of typically 5 or 15 minutes. It would not even be detected using 1 second intervals. For this reason, in addition to normal pressure logging intervals, the TransientMinder also constantly samples pressure at 128 times each second. From the lower of the two graphs shown here in blue, you can see that the second TransientMinder, which is 3.2 kilometers away, also picks up the transient event just 2 seconds later, meaning that the pressure transient took just 2 seconds to travel 3.2 kilometers, giving it an approximate pressure wave velocity of around 400 meters per second. And using this level of high definition information, together with accurate GPS timestamping, provided that the distance between the TransientMinder units is known and the pressure wave velocity can be estimated, the position of the event source can be calculated with reasonable accuracy. This is an example of TransientMinder being deployed in the field. At this point, I'll run a short 2-minute video to explain a little more about the system. Harmful pressure transients can and do cause bursts in all water distribution networks, resulting from a number of typical day-to-day operational activities such as valve operation. TransientMinder is born out of water utility research to better understand and address the effect of pressure transients. The TransientMinder itself is a small, easily deployed battery-powered unit housed in a rugged polycarbonate casing. It is fully insulation protected to a rating of IP68, which means it can be fully submerged, important for where the TransientMinder is to be deployed, typically in a below-ground chamber. The unit has an integral display and a number of LED indicators for on-the-spot status checks. The TransientMinder has an embedded 3G modem and is supplied with a GPRS antenna. The unit has a built-in GPS antenna for the highest level of synchronization accuracy and timestamping. This is particularly important for identifying the source of the pressure transient and not just the occurrence. There is an integral pressure transducer which can quickly and easily be connected via the supplied pressure hose to a number of access points within the water distribution network, such as a pressure tapping or fire hydrant, for example. TransientMinder is supplied with a choice of battery, either a fully potted lithium pack or alternatively an alkaline battery casing. Both battery options are IP68 and both can be easily changed locally by the user, avoiding the need to return the units to the manufacturer for battery replacement. Radar, Syrinix's cloud-based software platform, is the primary client interface to the data and information, although events, alarms and data can also be sent via SMS and email, or can be integrated into an existing client SCADA or graphical user interface platform. The TransientMinder's unique swarm analysis function can be used to identify the source and the cause of the harmful pressure transient. For more information on TransientMinder or any of the Syrinix range of advanced pipeline monitoring technologies, please visit syrinix.com. In exploring the most accurate methods of timestamping and clock synchronization to achieve the necessary level of transient source identification, we settled upon GPS and integrated a GPS antenna into the TransientMinder unit. In deploying a number of TransientMinder units across a linked pipeline network in what we refer to as swarm analysis, thanks to the rapid sampling and high accurate GPS timestamping, it is possible to identify and locate the source of the transient. As demonstrated by this illustration, within the space of just a couple of seconds, a transient pressure wave can be traced as it propagates through the pipe network, and with a little further analysis the source can be identified and the cause corrected or eliminated completely. A couple of examples of how TransientMinder is being used with our existing clients. Welsh Water has a large drinks producer located outside town but close to a residential area. Suspected by Welsh Water that transients were being caused by the use of non-return valves, the customer was not convinced and remained unwilling to change operational behaviour until evidence of transient was supplied. Existing loggers recording at 1 second intervals were not providing the level of detail required, so Welsh Water deployed 5 TransientMinders, 1 on site and the other 4 hydraulically linked in the residential distribution network. After just a month, enough data had been gathered to prove to the drinks producer that they were not only the cause of the transients, but to provide information proving that the transients were moving over 6 kilometres and spiking significantly, certainly sufficient to cause leaks and bursts in the residential areas. Welsh Water are now working with the customer to put procedures and alternative valves in place to reduce the transients. Another utility, Anglian Water, suspected that an inlet valve on a reservoir was causing transients, resulting in the neighbouring residential area being very prone to leaks and bursts. Detailed information from 5 TransientMinders was recorded pre and post the swap out of the inlet valve. Data analysed via radar provided a clear picture of transients that existed whilst the current valve was in place, and a burst in the residential area was also picked up and traced back to a transient caused by the inlet valve. The new inlet valve has smoothed the pressure activity, and transient monitoring with TransientMinder now forms an integral part of the pressure logging program within Anglian Water. Typically, our clients are initially deploying TransientMinder in numbers of around 5 units, with each unit costing around $3,000, plus $400 per year for data handling and access to the Radar Online software platform. We are currently working with many of our clients to build case studies around the findings, but at this stage we can confirm that using TransientMinder will help utilities deliver reduced burst frequency, reduced water losses, targeted predictive maintenance and prolonged asset life. What does Syrinix hope to achieve from TAG? Well, we recognise the importance of working with strong local partners, already approved suppliers to Australian water utilities, and we are in early stage discussions with a number of interested companies in this respect. We would of course like to establish initial paid pilot studies with utilities wishing to better understand network pressure event activity, then leading on to building a case study around those findings. And Syrinix does of course also offer the TrunkMinder and BurstMinder solutions, which we would very much like to see being used in Australia. We would be pleased to provide further information on these technologies. That brings me to the end of the presentation. I hope that provides you with a flavour for what the TransientMinder solution is about, and I'd be very happy to answer any questions. I'd also welcome your feedback on whether there is any truth to the recommendation that we should rename the TransientMinder system to TransientMate to make it more appealing to the Australian market. Thank you.